will be 5 minus x. That's this value. And then since the angle here is 60, you divide it in half. This will be 30, this angle will be 60, and this is 90. So it's a 30, 60, 90 triangle. With 30, 60, 90 triangles, so this is 90, this is 30, this is 60. With these, the rule is that on the 30, across from the 30 is x, across from the 60 is x rad 3, and then across from the 90 is 2x. So we can apply these values to this triangle. So, but first, what we'll do is that we are trying to find the largest area. So the area of this rectangle is, oh, well, we're using the largest area, but we're finding the dimensions. So the area will be length times width, so basically 2x times y. And then from here, we can go to try to plug in y. We can find y from this bit of the triangle, which I wrote out here. So this is a 30, 60, 90 triangle, and this side, the base of the triangle, is 5 minus x, and then this side is y. We don't have the hypotenuse yet, but it's like a part of the 10. So by applying the 30, 60, 90 triangle rule, we know that 5x is y. I mean 5 minus x is x. So then 5 minus x to find y, we multiply this by rad 3. So y equals 5 minus x times rad 3. So we can plug this into this equation. So area equals 2x times 5 minus x rad 3. Then from this we can distribute all of these to get 2x times 5 rad 3 minus x rad 3, then multiply this to this whole thing. And here we'll get 10x rad 3 minus 2x squared rad 3. From this gives us our area formula. From this, we're trying to find the dimensions of the largest area. So this will take the derivative of. So when taking the derivative of this, well, these two numbers are, you could rewrite this as 10 rad 3 and then x behind it. So then x of this, the derivative is just 10 rad 3. And then the derivative of this, you take the same thing, you could do 2 rad 3 x squared. This 2 goes down to the front, so it's subtracted by, this is 4 rad 3, and then subtract this by 1, so it's just x. And then set this equation, 10 rad 3 minus 4 rad 3x, equal to 0 to solve, because you're solving for x. So then to solve for x, you can add this 4 rad 3x to the other side. So we'll get 10 rad 3 equals 4 rad 3x. And then we have, isolate the x, and you divide this over, and you divide this over. These cancel. X equals 5 over 2, because reducing 10 over 4 is 5 over 2. So this gives you your x value, so that gives you one of your dimension parts. It'll be, yeah, this is one of it, and so then you have to plug this back in to this y equation in order to get your y value, which is the other part of your dimension. So y equals 5 minus, then plug in x, which is 5 over 2, times rad 3, and then this gets you 10 over 2 minus 5 over 2 rad 3. This is just still 5 over 2 times rad 3. This gets you, oh, you can just keep it at 5 over 2 rad 3. And then you multiply, this is your y, so then these are both your dimensions. So to write it out, you have 5 over 2 by 5 over 2, oh wait, no, because this x, when you go back to your triangle, is just one part of the whole length or side length. So one side length equals 2x. So then basically you just multiply 5 over 2 by 2, which just gets rid of this. So the dimension is actually 5. 5 by 5 over 2 times 3. And then those are your dimensions. Okay, for this type of problem, we have to analyze and then sketch the graph of this on the interval of 0 to 2 pi. So for the vertical asymptote, we use the denominator of this. So we set the denominator, which is 1 minus sine x, equal to 0. And so from this, we can add sine over, so we have 1 equals sine x. And then from this, you solve x, like where does sine of what value gets you 1. So you go over to the unit circle. I didn't fill the whole thing out. I just filled out the basic 4 lines. And then this is 0, this is pi, this is 3 pi over 2, and then this one up here is pi over 2. This one, pi over 2, is the only one where the y value, which is sine, equals 1, which is what we're looking for. So x equals pi over 2, and that's our vertical asymptote. And then for for x-intercepts, we set the original equation equal to 0. So we have 0 equals cos x over 1 minus sine x. So we can multiply the denominator over, since you're multiplying it by 0, it just becomes 0. So 0 equals cos x. And from there, we go back to the unit circle, and where does cos equal 0? It equals 0 at both pi over 2 and 3 pi over 2. So we go over here, and we have x equals pi over 2, and then 3 pi over 2. But what we have the vertical asymptote is actually at pi over 2, so we can't use this one. So our main x-intercept is 3 pi over 2. Then for the y-intercepts, we plug in, we do f of x, and then we plug in for x, we plug in 0. So cos 0 over sine 0. Oh, 1 minus sine 0, sorry. Which equals, and then you go into your calculator. When you do cos of 0, you get 1, and then 1 minus sine of 0, which is 1 minus 0, equals 1. So our y-intercept is 1. This is our x. Okay, and then for first derivative, we have our original equation is fx equals cos x over 1 minus sine x. So then to take the derivative, we do quotient rule, because this is the denominator. So from here we do low d high, which is the denominator. D high is d, like derivative of the numerator, which is sine x, or negative sine x, sorry. Okay, and then we subtract, and then now we do the derivative of the bottom, which is derivative of 1 is 0, so we just have cos x because that's the derivative of sine. And then we have the top, which is just cos x. Then all over the denominator squared. So 1 minus sine x squared. Then from here we go on and we multiply this all out, we distribute it. So here we'll have negative sine x minus or plus sine squared plus, and then we distribute this negative here, distribute it here as well, so both of these are negative. Multiply them together, we have positive cos squared x all over 1 minus sine x squared. And then here, from here we have sine, because when you look at this you have an identity, because sine squared x plus cos squared x equals 1. So we can just put this down to 1. We'll still have this left over, so 1 minus sine x over 1 minus sine x squared, the regular denominator. And then these are the same thing, so you can just cancel these out. And then we'll have 1 over 1 minus sine x. And this is the first derivative. Okay, and then second derivative, we'll take the first derivative, which is 1 over 1 minus sine x. And then for second derivative, we'll have to do quotient rule again. So 1 minus sine x, which is low, and then d high, derivative of 1 is just 0, subtract. Then we just take high, and then d low, derivative of 1 is 0, derivative of negative sine is negative cos, all over 1 minus sine x squared. Then from here, we'll divide this all out. This is just 0, so then we'll just have negative 1 times negative cosine, which is just cos x, all over 1 minus sine x squared. And then this is our second derivative. And then to find the critical numbers, we use the first derivative. So first derivative was, again, 1 over 1 minus sine x. And then we'll set this equal to 0. So we can, we'll set the numerator equal to 0, but 1 is just doesn't equal 0. So then we'll set the denominator as well to do the undefined. So 1 minus sine x equals 0. And then we'll solve this to 1. You add sine x to the other side, equals sine x. We did this similar thing in here, so we know, or for the vertical asymptote, so we know that critical number will be at x equals over pi over 2. From here, after finding the critical numbers, we move on to point of inflection, which we use second derivative for. So this is the second derivative equation that we have, and then we set that equal to 0. And then from here, we set the numerator to equal to 0, and then the denominator equal to 0. So then from here, we know that cos only equals 0 at pi over 2 and 3 pi over 2. So x here is pi over 2 and 3 pi over 2. we know that pi over 2 is our vertical asymptote, so we